Hello. This video is just in case you need a video from me for, let's see, Monday, November 15th or Tuesday, November 16th. So here's this video in case I give birth. What we're going to cover this time, let me turn on my camera. I guess I turned it off. What we're going to cover this time is the front side of 4.5. We did the back side pretty much together. And then, oop, there's the new camera. We did the back side pretty much all together. And then the answer key was left with the sub, so you can check it, or actually I'll just, zoom in here so you can take a screenshot of that. But what we're doing today is going to do 4.5 and talk a little bit about the practice test. So here, first thing we got to do before you do anything else, vitamin B, the bond angles are like, this structure is missing some things. So we're just going to correct it really quick so that it's like the picture is the way it's supposed to be. This oxygen is double bonded and has 2 lone pairs. This oxygen has 2 lone pairs. This oxygen has 2 lone pairs. The nitrogen has 1 lone pair. And watch this part carefully. Double bond, look up here, double bond, single bond, double bond, single bond, double bond. So pause this video and I'll zoom in even further and freeze it so it's not jiggly or wiggly at all. And this is what you need to correct the problem 2 on homework 4.5. It needs to look like this. So pause the video, do that. I guess I'll just let the video run for a second. I need to pull up mole view so I can draw you some molecules. All right, so zooming out, crunchy noises. I wish I had a camera that didn't make crunchy noises every time I zoomed in and out. Here's what happens every single year. Students get this paper and they're like, oh, this is so freaking easy. And then they go like this. Let me see if I can find a pencil so I can do it wrong and then I can erase it. I don't have a pencil, I guess. Here's what they do. They go, oh, look, angle 3, boop, boop, 90 degrees. And they write 90 degrees on the line and they get it wrong. And they look at this one and they're like, ooh, angle 4, whoop, 180, and they get it wrong. I don't know why it's so hard to see the all caps bold. This is not as simple as just looking and deciding because they aren't drawn accurately. The way that the pictures are drawn is what works best for the computer. That doesn't actually mean that that's how the molecule looks in like reality. So let me draw one and I'll show you. I'm going to do this one here. I'm going to do H. So I've got, let's see, let me zoom in on it. And by zoom in, I just mean I'll hold it up to the screen. All right, so there's the structure I'm looking at. And now with that on the screen and mole view here in the background, I'm going to draw this molecule. I have a carbon. Let's see. Carbon, click, carbon, click. And I need hydrogen, hydrogen, hydrogen with single bonds attached. I need a single bond between those two carbons and a triple bond where this is a, whoopsies, messed up, delete. I need that to be a nitrogen. Push the little broom so it cleans up my molecule. Check it out. It's basically the same thing, right? It's just turned a little bit sideways. Here is what's written on my paper. Same. You looking? But when I move this out of the way to reveal the actual shape in reality, whoop, let's see, 2D to 3D, bam. Yeah, check it out. That is not at all like a cross on the bottom here. So the shapes don't necessarily match. Let me draw one more just to illustrate the point. Let's do the one right next to it. I'll draw this one. Delete this whole thing. I've got a nitrogen, 2 hydrogens. I know it's super small on your end here, but when I connect the structure and make it do a little broom cleanup, it does make it a lot bigger, as you saw. All right, broom sweep, clean up. Here's my molecule. It already kind of looks different, but even still, I could make it look the same if I wanted to. I could, you know, put them all back in a straight line. It doesn't matter. Whoopsies. There we go. When I render it in 3D though, look at this. That's not the shape you were expecting, is it? Right? So anyway, the point of this is that the molecule shape in real life is not what actually what's printed on the paper. They do on the paper what makes sense for the computer to print. Back in the old days, it was easy to do like 90-degree angles. So here's the trick with these. The trick is you're going to count how many things are attached to the atom in question. Like, for example, this carbon number 5 that it's asking about, you're going to ask yourself, how many things is this carbon connected to? Well, on the one side, it's connected to an H. On the other side, it's connected to a carbon. It is connected to 2 things. When you are connected to 2 things, your bond angle is going to be 180 degrees. It doesn't matter that this is a triple bond. It's just thing 1, thing 2, and this was the molecule this was the carbon we were looking at. When you've got, let's see, new color. When you've got 3 things around your molecule, like number 6 here, it's kind of showing us, it wants us to look at, see how it's like going around that carbon. This carbon's the one we're looking at. It's attached to 1 thing, 2 thing, 3 thing. That carbon is attached to 3 things. 3 things means your bond angle is 120 degrees. The carbon over here is attached to, this carbon here is attached to 1, 2, 3, 4 things. It's got the 3 hydrogens, 1 oxygen. When you're attached to 4 things, the bond angle is 109. Now I did skip this one in the middle. It kind of looks gross at this point, but it's an oxygen bonded to a carbon also bonded to a carbon, and it's also bonded to 2 lone pairs. So not only does it have this connection here, 1, 2, are you looking? 1, 2, 3, 4. Lone pairs count as things that it's connected to. So that is also 109 because it has 4 things. Here's a better, more clear shot of what we're looking at. It's an oxygen. It has 1, 2, and then a lone pair, 3, 4. It has 4 things that it's attached to. 4 things means the bond angle is 109 degrees. The carbon here that it's asking about is 1, 2, 3, 4 connections. 4 connections, 1 O. So this is how you mentally go from what the picture looks like to what it actually is. It's important because the actual structure of the molecule determines what it does in the body. Structure determines function. So when you look at these pictures, you can play in mold view if you'd like sometime on your own. You can actually click angle, and I think my computer might be too old here, but you can click, okay, look, it's showing me my angle here. I took the angle on the nitrogen, and it says this angle here, zooming in, is 106.9, basically 107. Which is really close to what we predicted for this nitrogen. We predicted that that nitrogen would be 109. So, well, actually, we didn't because that's this problem. But I would go 1, 2, 3, 4 things attached. 4 things attached. I would have put 109, and this is the same exact structure that's on the screen here. I'm guessing 109, but in real life it would be 107, but that's pretty freaking accurate. The other thing that I would be looking at here is the oxygen, which is bonded to 2 lone pairs and 2 other steps. I would imagine, ooh, my marker is dying. I would imagine that this would also be 109. And in mold view, I can check. And this one, it's actually saying, oh, I think I measured it wrong. Let me redo this. It should be about 109. Let me re-render it. 2D to 3D. Reshow my molecule. Why aren't you cleaning up? I don't want to redraw you. Oh yeah, for sure I took the wrong angle, but that's okay. Oh, maybe not. 99. It's not quite 109, but it's a lot more accurate than what it looks like on the thing. It looks like it's a straight line at 180. It is definitely not. This one over here is though, because this carbon is attached to 1, 2 things. When you are attached to 2 things, you say that is 180. The next part, we fixed the picture by adding lone pairs and multiple bonds to make it correct. And now what we're doing is giving the approximate values for angles A through G. So for angle A, it's talking about this oxygen. Same as up top. 1, 2, 3, 4 things. It's got 4 things attached to it, means 109. This carbon has 1, 2, 3 attachments, 120. A, B, C, this has 2 bonds, 2 lone pairs, 109. Here's the trick. Once you have all of this done, when it asks for which carbons are tetrahedral, tetrahedral being the shape that has 1, 2, 3, 4 things around it, you just have to go back and look and see which carbons are at 109. 109 means tetrahedral shape. When it says how many are, this should say trigonal, cross this out, trigonal planar. To figure out if something is trigonal planar or not, just look and see which ones are at 120. I will leave the answer key with the teacher, with the sub, and you can check your work. But essentially, it's just really simple. How many things are attached? 1, 2, 3. 3 things are attached, and the bond angle is 120. The last part here was more building off of what we did last time. Define the following vocabulary words. Electronegativity, I would say, is how hard an atom is pulling on the bonded electrons. This is straight from your notebook. When you've got 2 atoms that are bonded and one is pulling harder than the other, it is more electronegative. It is a polar bond when it's shared unevenly. Let's see. Shared electrons and how much pull an atom has on those shared electrons. A polar bond is when the difference in electronegativity is between 0.5 and 2.0. It just means that they're sharing unequally. Non-polar bond then is when they're shared pretty close to equally, maybe not 100%, but the difference is small, less than 0.4. And all of this is from notes 25. The difference between a lone pair and a bonded pair, lone pairs kind of look like this. They have their own space. Bonded electrons look like this. They connect atoms like you had an H and then F or something. They would connect. So that's how they're different. The Venn diagram, ways that they are the same is that they both have 2 electrons. It's just depending, do those 2 electrons get their own bubble, or are the electrons being used to make a bond? So there's homework 4.5. It's kind of a random assortment of all of the steps. And the last thing left in the chapter then you would think that we would be doing 4.6. In all of your stuff, it says 4.6 intermolecular forces. It says notes 26 intermolecular forces. We are not going to do intermolecular forces. We're actually moving that into unit 5. We'll start unit 5 with that. Don't worry about it. I just don't want you to forget it by unit 5. So I thought instead of learning it now and having time to forget, I'll just move it into unit 5 and we'll start with that. So this chapter, the last homework that you'll turn in is homework 4.5. Don't get rid of 4.6. If you do, I will print you another one, but I will give you like the deaths there. So don't lose 4.6 or any of the cutouts, or I'm gonna have to reprint them for you. But 4.5 is the last homework for this module. Meaning that we need to do some modifications on this practice test, because the practice test was written thinking that we would have 4.6 intermolecular forces on it. Today, for the rest of class, you're going to complete the practice test. You will be able to do problems 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 here is going to get crossed out. See how it says, explain the difference between a chemical bond and an intermolecular force. We're not dealing with intermolecular forces right now. So cross that one out. And then on the back side, guess what you're going to cross out? The directions say identify which force is being shown. The entire backside, we're going to skip. I will reprint you a new backside once we get to this point in time. But we are not doing IMFs, whatever those are, not doing IMFs in this module. So for the rest of the class, you're going to be working on doing the practice test. I will leave an answer key for you. And on the answer key, I tried to be really, really specific on how I did the problems. And hopefully that will be sufficient for you in order to do well on the test. The test is very similar to the practice test. Just a reminder, it didn't print super great. So when you're doing the problems down here on bottom, these are just artistic bonds, whether they're blackened or shaded lightly. All of these are just artistic bond, 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 bond. And the big fluffy clouds are your lone pairs of electrons. I'm not saying you have to go through and color all of them in, but I would at the very least put in your lone pairs. Okay, so that's the video for today. Please make sure you're working efficiently. Make sure that you're more than welcome to work by yourself. You can work with your table mates. I'm sure you can move around and work with your friends if you're already not sitting with them. But by the end of the period, you should for sure have this practice test finished, and you should work with the teacher on checking your answers. So there you go. Good luck on your test. Your test next time will be printed It will be printed out. Your substitute will hand it to you. You'll take it just like normal, turn it into the basket at the end of the period. I will probably have my husband or something run to the school and pick the test up, or maybe I'll have Mr. Kohler, the student teacher, grade them all so I don't have to. That would be lovely. But you're just going to take it like regular. The front half is multiple choice. The back side is free response. The multiple choice questions are very similar to the ones here, where they ask you to name something. What is the formula for ammonium hydroxide? What is the name for the compound Ti parentheses OH2? Stuff like that is in the multiple choice section. Stuff like draw a certain molecule like this. I copied and pasted several problems from the homework onto your test. So these are the ones that you will need to draw on the free response portion. Okay, good luck.